Okay, we're talking about resistors in series and parallel, and here's a summary of what we have said so far. In series, the currents are the same and the voltages add up. So if you have two resistors in series, R1 and R2, and the current going through resistor 1 here, we'll call that I1, and the current going through resistor 2 is I2, and the voltage in resistor 1 is V1, and the voltage in resistor 2 is V2. What we're saying when we say the currents are the same, we're saying that I1 has to equal I2. Every electron that goes through one resistor has to go through the next one as well because there's only one path. And the voltages add up. That means that the voltage here, V1, plus the voltage there, V2, adds up to the total voltage. So if we took this pair of resistors as a whole and called the voltage V, for that set of resistors, then V would equal V1 plus V2. And for resistors in parallel, the voltages are the same and the currents add up. So in this case, electrons are coming down this wire and then they split. And some go down one side and some down the other, and then they rejoin down here. And we'll call these R1 and R2, and we'll say that the current going through this one is I1 and the current going through this one is I2, and we'll say the voltage in this one is V1 and the voltage over here in this one is V2. Now what we're saying is that V1 and V2, the voltage for those two resistors, these guys are equal to each other. And if you were to consider this network of resistors as a whole and say it would have some voltage V, that would be the same as V1 or V2. So V1, and V2 are the same in this case. And the currents add up. The current going through this resistor, what we've called I1, and the current going through this resistor, what we've called I2, those have to add up to the total current coming into this network of resistors. Because whatever total current there is has to split, and some goes down one side and the rest goes down the other. So if you call the total current coming in here I, then I has to equal I1 plus I2. So in series, the currents are the same and the voltages add up, and in parallel, the voltages are the same and the currents add up. Now let me make one more comment about series and parallel circuits. Take a look at this circuit. These three resistors are in parallel, and here these three resistors are in series. Okay, and that's easy to see, but sometimes it's not quite so easy to see. Take a look at this. What if I had the wire run like this, and there's a resistor, and then it runs like this, there's another resistor, and then there's another resistor there. So that's series and parallel. It's important to understand that this is a series circuit. Even though these three resistors are geometrically lined up parallel to each other, that doesn't matter. What matters is where the current goes. And in this case, there is only one path for the current to flow. It goes through resistor 1, and then resistor 2, and then resistor 3. And that is the essential aspect of a series circuit. If there's only one path for the electrons to flow through, then those things are all connected in series. If it branches, then it's a parallel circuit. And whether it does that or not is independent of whether the resistors are actually lined up parallel to each other. So the geometry of the diagram in that sense isn't the critical thing. The critical thing is whether the current branches or not. Or think about this circuit. Here's our battery, and imagine the wire comes here and there's a resistor there and there's a resistor there, and then this wire connects back here and this one comes around and connects there. Now these two resistors, even though they're lined up in a straight line, they are in parallel. They're not series. The electrons come out of the battery and they get to this point right here, which we call a node, and they divide, and some go this way and some go this way. And the ones up top come around the side of the circuit here, and the ones on the right side come around here, and they come back to this point, which we call a node, and the current rejoins. So the current divides, goes through those two resistors, and then rejoins. So those are in parallel by definition. And that's the essential aspect of a parallel circuit. The current divides. And again, that's independent of whether they are physically lined up in a line or not. So those are the main ideas about series and parallel. You can memorize these 4 facts. In series, the currents are the same and the voltages add up. And in parallel, the voltages are the same and the currents add up. And memorizing those is good, but it's far better to actually understand them. If you understand what series and parallel circuits are, and what current is, and what voltage is down at a fundamental level, then all 4 of those ideas should make sense. And even though memorizing them is okay, it will be far easier to remember those facts if those concepts make sense to you. So strive for an actual understanding, not just for a rote memorization of the facts.